One of the oldest types of organic chemical reactions that was ever studied is this one here that creates esters. And it's really kind of hard to talk about what an ester is all about without talking about how it's created. This can be done in a laboratory, but it's done naturally all the time. And there are many naturally occurring esters. They are characterized by their generally pleasant odors, but they're always very distinctive. And they always have odors quite different from the acid and alcohol that they're made from. And the naming of esters is based on how they are created as well. So I'll see a few examples of esters, but we'll first talk about how they're made. And if you can name the acid and alcohol from which they're created, there's a simple rule for how you go about naming the corresponding ester. As you can see, water is a byproduct of this reaction. Essentially, you take two hydrogens and an oxygen away from among the acid and alcohol, and the fragments containing the carbons bond to one another, and that is literally what an ester is all about. Here's the simplest case, a one-carbon acid reacting with a one-carbon alcohol. So we've got methanoic acid and methanol, and I've color-coded the elements that end up making the water molecule, because this reaction has been studied and its mechanism is well known, and it's known that we take the OH from the acid and just the hydrogen here from the hydrogen on the oxygen in the alcohol, and then the new bond, the ester bond, is between that carbonyl from the acid and it connects to that oxygen from what used to be the alcohol. So the acid is no longer an acid, it's neutral. And what's nice about doing such reactions is that the ester generally is not soluble in water, so it separates as its own layer. And so you can see it forming, and you can certainly smell it forming, because it's bound to be quite unique in odor. Down at the bottom, I just showed the same process without the color coding there, circling the atoms that end up making the water. As far as drawing the ester, you could imagine you take the OH from the alcohol and just the hydrogen from the acid. That would lead you to the same structure. And that's kind of, I guess, what they have in mind when we name esters. Because this name, methyl methanoate, well, methyl is CH3, and methanoate is what you call an acid if you just are missing its hydrogen from that OH group. So if I cover up the H in methanoic acid, the anion, the negative ion that would be left, would be called methanoate. So anyway, esters made from any acid have this OATE ending. That's the suffix that says it is an ester. And the second name tells you essentially which acid it was made from. The first name of any ester involves whatever alcohol is being used. And in this case, since we've added a methyl group, we are using methyl alcohol, so therefore we're making a methyl ester. A couple of other examples, also about the next simplest cases I could show you here. The 2-carbon acid, ethanoic acid, you can react that with methanol, and generally these are liquids that would be reflux. You can speed this up by using a catalyst like sulfuric acid or phosphoric acid. But again, as far as the organic product, you make the corresponding ester. So in this one, it's still a methyl ester because we're still using methanol, but now it's ethanoate. And the other common name for ethanoic acid, if you recall, this is also acetic acid. It's called that more often than it is ethanoic. And so the corresponding esters from that are called acetates. So methyl acetate is another name for that first ester. And in fact, in this bottom example here, ethyl ethanoate is, when I purchase it anyway, it's always labeled in a bottle that has ethyl acetate on it. Either last name is correct though. But generally, esters made from a 2-carbon acid are going to have the name acetates. Ethyl acetate, by the way, is a very common solvent used in organic chemistry, a good alternative to alcohols. And this is also the compound that's used as fingernail polish remover in a lot of cases. Acetone or propanone is a fingernail polish remover. It's essentially a good paint thinner, but so is ethyl ethanoate or ethyl acetate. Well, now you see how esters kind of come together. Here are some that are already created by nature, as you can tell. The natural flavorings or odors of many fruits and things like that are due to esters. So our nose is very good at detecting these. That first one, again, ethyl, from the fact that there's this ethyl group here. And so the way esters are generally drawn, the alcohol atoms kind of come, or they tend to be drawn on the right-hand side of the molecule, even though they become the first part of the name there. So ethyl methanoate, if you like rum candy or just the smell of rum in general, that is because you like the odor of ethyl methanoate. All of these are liquids, but they evaporate very easily. Pentyl is the name for pentanol or pentyl alcohol. That's the 5-carbon fragment you see there. And if you like bananas, you like the smell of pentyl ethanoate, or pentyl acetate it could be called. These last two are both butanoates because they're both derived from butanoic acid. Butanoic acid has this awful odor. It's associated with rotten food. If you leave something in your refrigerator for a few months, oftentimes the bad smell that results is from the release of butanoic acid. But the esters that you can create from those have pleasant odors. You can see one of these corresponding to apples and the other pineapples. The difference just being one is a methyl ester and the other is an ethyl ester.